Good morning, everyone. I am Michelle Mengqing, General Manager of Electronics and Physics Business Department of SPTL. Today, I am very glad to have Ms. Yuan Yi here as our speaker. Ms. Yuan Yi is one of the key members of our big team. She graduated from National University of Singapore as a master with her research interest on graphic processing. After joining in SPTL, her interests have extended from graphic processing to communication technique as well as artificial intelligence. Moreover, as a senior attorney, she is very good at drafting, prosecution, and litigation. Today, her topic is about AI-related applications in China. Okay, now let me hand over the microphone to Ms. Yuan Yi.
Thank you, Michelle. Hello, everyone. Many thanks for your attendance today. I am Yuan Yi, a patent attorney from Electronics and Physics Business Department at SPTL. I am very pleased to share with you some up-to-date information on AI applications here in China. The function and popularity of artificial intelligence are soaring by the day. Artificial intelligence is the ability of a system or a program to think and learn from the experience. AI techniques have significantly evolved over the past few years and have found their applications in almost every business sector. Therefore, we expect that AI patent applications will be hotter in the coming decade. Here are the things we are going to talk about in today's presentation. Firstly, we would briefly introduce the background of today's topic. Then, we will discuss some kinds of rejections and objections that AI applications often receive. In the end, we will give some summarization and tips on this matter. All right then, first, let's get started with the background. We know that a couple of years ago, AI applications were not likely to be allowed in China, since they were regarded as being rules and methods for mental activities. So, what are rules and methods for mental activities? Here we have a simple example. Chess is regarded as rules and methods for mental activities, since the rules for playing chess are defined by man rather than by nature. But we know AI applications are non-stoppable. Indeed, they have found applications in a lot of business sectors and helped to improve their effect or efficiency. Therefore, by the end of 2019, the CNIPA issued amendments to the guidelines for patent examination, which recognizes that AI applications, when meeting specific requirements, are allowable subject matter. To help better understand what kind of AI applications are allowable, new amendments to the guidelines for patent examination are currently requiring for comments. In the pending draft, several further examples are given, showing what are allowable AI applications. We will have a look below. So, what's the key point to make an application allowable? The answer is very straightforward. That is, it shall get involved with the 3 T factors, say, technical problems, technical means, and technical effects. In short, an AI application shall use technical means to solve technical problems, and then shall achieve technical effects as a result of doing so. Otherwise, an AI application would still be taken as rules and methods for mental activities and thus are not allowable. In relation thereto, other rejections and objections are possible. Next, we will have a further discussion. Of course, for an AI application, the most common rejections are Article 2.2 rejections. Article 2.2 requires that the subject matter be a new technical solution. The guidelines for patent examination further requires that a claim shall not concern only rules and methods for mental activities. Why were AI applications previously regarded as rules and methods for mental activities? Because machine learning, deep learning, neural network, etc. are thought of as being man-devised algorithm rather than something natural or technical. As we know, machine learning typically involves a neural network, also called as a model, which comprises several layers of cells called neurons. The neurons are linked by synapses. A synapse typically represents a weight value to be multiplied with the input. The neuron receives several weight input and then gives an output according to some function. To train a model, a set of training dataset is fed into the neural network. The training data often has a label showing the correct result of classification of itself. If the final output from the model is different from the label, then this information is used to adapt the weights of the neurons until finally the output is sufficiently close to the label. As we can see, the entire model seems to be non-technical. A model seems to be independent of what kind of data is input. If you input image data, it may output classification result for image recognition. For example, it may determine whether the input image is a cat or a dog. But if you input data of user information, it may output classification result for the identified abnormal users. The model per se seems to have no significant adaptation when used in different business sectors. That is why the CNIPA previously thought such models were non-technical, and accordingly were rules and methods for mental activities. However, we suppose it somewhat unreasonable. Why something that can help solve technical problems or is part of the technical solution cannot be protected? It seems that a lot of applicants had the same question. So the CNIPA has relaxed the restriction. The key point, as we just talked about, is for the AI application to have close relationship with the 3T factors. Say, to use technical means, to solve technical problems, and to achieve technical effects accordingly. If an application shows the 3T factors, Article 2.2 rejections may not be raised. But since AI applications have not become allowable subject matter for a long time, some examiners may still think in the old way. If the examiner raises Article 2.2 rejections, what can we do? Or how can we even prevent such rejections from the very beginning, say when drafting the application? We need to reflect that the AI-related features have close relationship with the technical problems. For example, if the data processed in the algorithm has technical meaning, then the algorithm is regarded as having close relationship with the 3T factors. As another example, if the execution of the algorithm reflects use of natural rules, then the algorithm is regarded as having close relationship with the 3T factors. In the pending draft of amendments to the guidelines for patent examination, further details are given for AI applications involving improvements of AI techniques, such as deep learning, classification, grouping, etc. For example, if the algorithm is technically related to the internal structure of the computer system, or if the algorithm can improve hardware operation efficiency or effect, then the algorithm is regarded as having close relationship with the 3T factors. So, how to reflect the internal structure of the computer system, or the capability of improving hardware operation efficiency or effect? Here are some examples. For instance, if the algorithm helps to reduce data storage volume or data transmission volume, or if the algorithm helps to increase hardware processing speed, etc., then the algorithm can be regarded as having close relationship with the 3T factors. On the other hand, for AI applications of specific industrial scenario, you had better show that in data mining, classification, grouping, or other manipulation, the algorithm uses internal association of the data in compliance with natural rules. As another example, if the algorithm enhances reliability or accuracy in big data analysis in a specific industrial scenario, it can be regarded as having close relationship with the 3T factors. Now, let's have a look at this new example in the pending draft of amendments to the guidelines for patent examination. We may have half a minute to read it. It's a method for training a model. The first step is to calculate training time for a changed dataset. The second step is to select a training solution having a shortest training time. And the third step is to perform model training. Please focus on the feature underscored, which reads, wherein the candidate training solutions comprise a single processor training solution and a multi-processor training solution based on data parallelization. Under previous criteria, this claim was not allowable, since it has no apparent or explicit relationship with any specific industrial background. Single processor or multi-processor training solutions are common knowledge. The inventiveness lies in the improvement on model training. Nothing seems to be very technical. But according to the attitude of CNIPA, this is now very likely allowable subject matter. Let's have a look at the analysis given in the pending draft. Firstly, the CNIPA indicates that the technical problem to be solved is the low training speed. That is, the purpose of this solution is to increase the training speed of the model. To do so, the algorithm chooses different training solutions, say single processor or multi-processor training mode, for training data of different sizes. Therefore, it is regarded as improving the performance of the computer system where the model is running, and thus having close relationship with the 3T factors. Another kind of rejections that AI applications often receive is Article 22.3 rejections. As we know, Article 22.3 involves inventiveness. An AI application typically involves both technical features and non-technical features. If the non-technical features do not have close relationship with the technical features, then when the examiner evaluates the inventiveness, he or she will take only the technical features into account. In order for the non-technical features to be factored in evaluation of the inventiveness, they need to get involved with the technical features. For example, technical and non-technical features need to support and interact with each other. Now, let's move on. How can we prevent or address Article 22.3 rejections? In the AI applications, you need to get the algorithm features involved with the technical features. For example, if the algorithm is applied to a specific technical field and can solve a specific technical problem, then it has close relationship with the 3T factors. As another example, if the algorithm is technically related to the internal structure of the computer system, or is capable of improving hardware operation efficiency or effect, then it has close relationship with the 3T factors. So, how to get the algorithm features involved with the technical features? One way is to apply the algorithm to a specific technical field, so as to solve a specific technical problem. According to the examples given in the pending draft, the algorithm may be technically related to the internal structure of the computer system on which the algorithm is running, and accordingly achieve improvement to the performance of the computer system. As another example, we may show that the algorithm is capable of improving hardware operation efficiency or effect. For example, when the algorithm can reduce data storage, or reduce data transmission, or increase hardware processing speed, etc., it has close relationship with the 3T factors. As another example given in the pending draft, if the algorithm features and technical features functionally support each other and interact with each other, such that they work together to bring about or produce enhancement of user experience, then the algorithm features have close relationship with the 3T factors. Now, let's move on to a new example in the pending draft. Let's read the claim first. It is a method for adapting parameters for a neural network. The first step is to select dimensions for a weight parameter. The second step is to determine a size of the weight parameter. The third step is to determine candidate values of a target size of the weight parameter. The fourth step is to select subsets of candidate values. And the last step is to populate the weight parameter according to a target dimension. This claim does not reflect any specific industrial background. Indeed, according to the previous criteria, it was merely some kind of data manipulation. Please note the feature underscored. It shows the key relationship between the algorithm with hardware performance. For this example, the CNIPA gives the following analysis in the pending draft. The solution of this claim involves populating or padding the weight parameter to the target size. This feature does not use natural rules. Obviously, it is a kind of data manipulation defined by man. This is apparently non-technical. However, this algorithm does have some technical effect. It enhances the processing efficiency of hardware. As mentioned in the last slides, candidate values of a target size of the weight are determined according to a utility rate of the hardware supporting calculation of the neural network. This shows close relationship between the algorithm features and the 3T factors, and thus the algorithm features can be accounted for in evaluation of inventiveness. In addition to the above, AI applications often receive Article 26.3 and Article 26.4 rejections or objections. Article 26.3 requires sufficient disclosure of the invention. Sufficient disclosure means that the description shall be sufficiently clear and complete, so as to enable a skilled one to carry it out. Therefore, for AI applications which are applied to a specific field of application, we'd recommend to detail how the input data is prepared, what relationship it has with the field of industry, what the output stands for, or how it is technically useful. These details help to build close relationship with the 3T factors. On the other hand, for AI application which involves the improvement of AI algorithm per se, it is our suggestion to expand on how the algorithm is related to the internal structure of the computer system, or how the algorithm interacts with the hardware. Especially, if possible, please elaborate how the algorithm improves operation efficiency or effects of the computer system or hardware. For example, how the algorithm reduces data storage volume, or reduces data transmission volume, or increases hardware processing speed, etc. All these details help to build close relationship with the 3T factors. Article 26.4 requires a claim to be supported by the description and to be clear. That is, if algorithm feature is to be put in claims, it had better be described in the description in a detailed manner. If the algorithm feature involves any generalization of the described embodiments, please make sure enough embodiments of diversity and different abstraction levels are given to support such generalization. Besides, some algorithm features are abstract and do not show clear and explicit relationship with the real-world technical factors. It is our suggestion that, in both the claims and the description, such implicit relation shall be explained, clarified, or elaborated. In summary, it's the key point for AI applications to have algorithm features in close relationship with the 3T factors, say technical problems, technical means, and technical effects. This helps to address both Article 2.2 and Article 22.3 issues. Further, it is also necessary to have sufficient disclosure of such close relationship in the description. That is the end of my presentation today. Thanks for your listening.
Thank you, Yi. Now we enter into our Q&A section. Let's see what kind of questions do we have. Okay, we have 2 questions here. The first one is from Mr. Kevin McBride. His question is, the 2 examples both incorporate hardware-related technical features into the solution. Does that mean only software-related features might be quite hard to avoid rejections? Yi, please.
Okay. Actually, solutions with only software-related features might be accepted as a technical solution, as long as the solution gets involved with the 3T factors. As an example, if a solution is used to improve efficiency of graphic processing, or if a solution is used to reduce, say, the amount of data to be processed, I suppose we have sufficient grounds to traverse these rejections. Michelle.
Okay. We have the second one. The second question is from Mr. Zanis Zhang. He asks, shall we describe all the 3T factors during prosecution? Yi, please.
Okay. Not necessarily. I do remember that in prosecution, we have succeeded in cases where only 1 or 2 of the 3T factors are explicitly described or deceivable in the application document. Of course, it will be easier for us in prosecution if all the 3T factors are clearly described and explained in drafting. Michelle.
Okay, that's the 2 questions we got right now. Since it's nearly midnight at our side, we will finish our webinar soon. If you have any further questions, please contact us anytime. Thank you for your attendance and thank you for your listening.